Professor Belfrost's science class is back.
Hi, welcome back, and you're in my mathematics class again today. And today we'll continue your lesson on equation and inequalities. I think this is the fifth video on equations and inequality chapter. So let's do some review of our previous lesson. So an equation containing a second degree polynomial is called a quadratic equation, and it is easy to solve this by factoring, which means we find expressions that can be multiplied together to give the expression on one side of the equation. And when there is no linear term in the equation, that we can use square root property is that we isolate the x squared term and take the square root of the number on the other side of the equal sign. Okay, and given a quadratic equation with an x squared term but no x term, they can use this square root property to solve this. Okay, but not all quadratic equation can be factored or can be solved in the original form using the square root property, and in this case then we may use a method for solving quadratic equation known as completing the square method. And a quadratic formula not only generates the solution to a quadratic equation, but it can tell us about the nature of the solution when we consider the discriminant, which is b squared minus 4ac. And the discriminant tells us whether the solutions are real number or complex numbers and how many solutions of each type to expect. Next is a rational exponent or exponent that are fractions, where the numerator is a power and the denominator is a root. And a rational exponent indicates a power in the numerator and a root in the denominator. And we have used factoring to solve quadratic equation, but it's a technique that actually can be used in many types of polynomial equations, which are equations that contain a string of terms, including numerical coefficient and the variables. And when we are faced with an equation containing polynomials of degree higher than 2, then can often solve them by doing the factoring thing. What's a radical equation? Radical equation are equations that contain variable in a radical, such as square of 3x plus 80 equal x, and so on and so on. Radical equations may have one or more radical terms and are solved by eliminating its radical one at a time. Done for the review. Let's move on to our today's lesson. So now we'll learn about absolute value equation. So to solve an equation such as absolute of 2x minus 6 equals 8, that we notice that the absolute value will be equal to 8 if we substitute x to be minus 1 or 7. Okay, and then we can solve it as shown in the slide. So knowing how to solve the problem involving absolute function is very useful. So here are the properties that are used to solve this kind of problem. So if x is greater or less than 0, greater or equal than greater greater than or equals 0, then absolute of x is x, and if x is less than 0, then the absolute of x is minus x. So for real numbers a and b, an equation in form of absolute a equals b with b greater than or equals 0 will have a solution with a minus b or a equals b. If b is less than 0, then the absolute a equals b has no solution. So here's a summary that you maybe need to take notes on. And let's practice with cases. Okay, so the first problem, we see that this is a positive. So no problem, we just need to follow the steps. Okay, so 6x plus 4 equals 8 and 6x plus 4 equals minus 8, and then simplify them. So there are two solutions. How about b, which is square root of a square root absolute value of 3x plus 4 equals minus 9? It's very clear that this is not possible. Absolute value will never be negative, so this has no solution. C, you need to rearrange the term first, constant on the right hand side. So this is actually absolute x minus 5 equals 10, and then you can just solve it as 3x minus 5 equals 10 and 3x minus 5 equals minus 10, then simplify it. Also, there are two solutions for C. How about D? If you meet this condition, this is a very unique condition, equals 0, there only one solution, and this is 2 in this case. Next, solve the equation in quadratic form, and this is the equation with three terms. So the first term has a power other than 2, then the middle has an exponent that's 1/2 the exponent of the leading term, and third is a constant. It's shown as a slide here. A few examples. So yeah, there are 6 steps that you need to follow when you want to solve this kind of equation. I'll narrate it one by one to you, so you need to evaluate it by yourself. You'll just see how to solve it by example. So here are fourth degree question you need to solve. So yeah, first you need to make us you need to take, for example, you say x squared is u because you made this term, and then you can create new equation which is 3u squared minus 2u plus 1 equals 0, uh, and later you can just substitute the u value to be x squared after you solve. Okay, now you can just solve it as the regular quadratic equation, and after it you just need to replace the original term of u with 2x, with x squared I mean, and do the kind of factorization as usual. Here's the solution is plus minus I square of 1/3 and plus minus 1. Here's another problem to practice on. So here's the equation. I'll not read the equation, but here you take x plus 2 as a or u. It's up to you, for example. So let u equals x plus 2. They can rewrite the equation and solve it as before. Okay, here also there are two solutions, which is minus 40 and minus 1 in this case. Okay, so how to solve for this? Actually, it's very easy, right? Okay, and yeah, earlier we have solved differential equation, but sometimes our differential equation result in a quadratic. So it may turn out that this may lead us to no solution at all. So let's see when this thing happens. For example, we have this example with us. So first, for this, we really want to take the LCD of the denominator, and you see in this case this is x squared minus 1. It's very clear, right? So we have x squared minus 1 as the LCD, and then we just need to multiply the whole equation by this LCD. But then we find out that x is minus 1 and x is 1. But actually, the excluded excluded solution also minus 1 and 1. So actually this will leave us with no solution at all. Okay, here's also a number line with we have discussed in the first chapter, but actually here we'll use it for showing a solution set. Okay, so yeah, for the number line shown in the figure, how can we express the solutions? Actually, you can use set builder notation as shown in the slide that translate to all real numbers x such that x is greater than or equal to 4 is the solution. Okay, so we have discussed um, two way to express the solution set notation. Now the third method is the interval notation, which solution set are indicated with parentheses or brackets. So for the solution to x greater or equals 4, then this can be represented as bracket for left bracket 4 comma infinity closing parenthesis. Okay, this is very easy, right? So the main concept to remember is that parenthesis represents solution greater than or less than the number, and bracket represents solution that are equal to or less than or equal to the number. Also, for infinity and negative infinity, we use parenthesis and never use bracket. Okay. So here are the summary. I want you to investigate by yourself. Now, let's practice. So use interval notation to indicate all real numbers greater than or equal to minus 2. So there's a way we write in. And write the interval expressing all real numbers less than or equal to minus 1 or greater than or equal to 1 as the solution. So I want you to investigate by yourself how we express it. Oh, okay. So if we want to express OR, we use the union. union notation, but if we want to express and, we use intersection notation. Okay, so when we work with inequalities, we can usually treat them similarly to, but not exactly as we treat the equalities. So there are some properties of inequalities. You can see there are two properties, which is addition and multiplication. Maybe for addition is quite easy, but for multiplication and division it sometimes will be a little confusing when we are when we are multiplying or dividing by a negative number. That we need to reverse the inequality symbol. Let's illustrate the concept by investigating the example below. Okay, so we have three problems to be solved. Let's see. So yeah, for the first one is rather easy. Second one is also easy. Third one is also easy because it has an involved multiplication. Okay, and the addition just works as it should be. Okay, but how about multiplication, which is the next example? The A shows us the regular one. You just need to divide 3 to both sides and get the solution. But for the second one, after rearranging it, it will becomes minus 2x greater than equals 6. And here you need to divide both sides with minus 2. But for negative number, you need to remember that you need to reverse the sign after you do the operation. Okay, that's the trap actually. How about C? Actually, C we also live with minus x, which is we need to divide by minus 1, and then we need to reverse the operation symbol. Okay, so here's another example that we need to solve the inequalities here. So yeah, how to solve for this? Actually, it's very easy. First, we need to group symbol with variable with variables and constant. Okay, so variable on one side, constant on the other side. Then we can just solve it as shown in the slide. Then here another example on inequality. Okay, we have kind of fractional things here. But actually, don't worry, you just need to find the LCD of the denominators and you can just solve it as regular. Okay, I really want you to investigate how to express the solution set in interval notation, because this is something that you'll always kind of encounter in mathematical problems. Okay, now we have compound inequality. Okay, so it includes two inequalities in one statement. Okay, but how should we work with this? Actually, you need to just separate them into two separate inequalities. Okay, to solve this. For example, here's the example. So you have 3 is less than equals to x plus 2 less than 6. So you take the first and the second expression and solve for them, and then second and third to solve for them. Okay, that's how you work with it. And then you just need to combine the solution set and see if there is some intersection, or if there's no intersection, there is just all of this to be the solution set. Okay, so this is another example I want you to evaluate by yourself. Actually, that's not very difficult. Okay, so an absolute value inequality is an equation of the form. This is a new thing for you, right? So yeah, there are four forms that you can encounter. So for an algebraic expression x and k is greater than 0, then absolute value inequality is an equality to the form of the absolute x less than k is equivalent to minus k less than x less than k, and absolute value of x greater than k then is equivalent to x less than minus k, or x is greater than k. And this statement also applies to less than equals and also greater than or equals form. Okay, so I want you to now this is actually our final part of our chapter. So here's another problem that you need to solve. Suppose that we want to know all possible returns on an investment if we could earn some monies within 200 to 200 of $600. So we can arrange the equation as shown. So minus 200 is less than equals x minus 600 less than equals 200. And then we can solve and find that our return is about 400 and $800. Okay, now let's practice with another example. So say that we need to describe all values within distance of 4 from the number of 5. It means that actually uh, the absolute value of x minus 5 is actually less than or equals 4, right? So the solution, the range is actually x is less than 9, less than or equals 9, and x is greater than or equals 1. Actually, that's the solution. Here's another one. I want you to investigate by yourself. Okay, actually, we have done with this chapter. So before I end this discussion, here's a little quote for you. So Niccolo Machiavelli once said that where the willingness is great, then the difficulties cannot be great. Okay, so that's good for you. Thanks for watching. Subscribe, give a like, comment, and share this video. So I'll be back on every Tuesday. Actually, I haven't renewed my slide. Okay, the new schedule is only on Tuesday. Keep watching and don't forget to visit the website to get new learning resources every month. Okay, and I'll stay here and see you. If you have any question that you may drop a comment, I'll answer it. Okay, if I have time. Okay, thank you. See you.